Hello everyone. So welcome back again. This is the session 2 of our lectures. So the classes are of alternate weeks. So you can expect the recordings every 2 weeks. And we only have the office hours. So if any of you want to come to office hours, you can come any week. So I'm conducting office hours every week between 4:30 to 5:30. The same link which is posted on the module, also in the course outline. And I'm sharing my screen with you. Sharing the screen, sharing the screen. And I hope you see my screen right now. I'm putting it in presentation mode. So, introduction to business analytics. So, we are talking about analyze the data, where you will use basic statistical knowledge as well as analytical knowledge. And you can use also some tools, okay, in the business analytics. So over here, so where do we fit in the SOAR model? There is a SOAR model, SOAR model. Specify, observe or obtain the data, and also you have analyzed the data and report the results. This is the SOAR. We are going to talk about analyze data using the statistical tools. What is the population? What is the sample? What are the sampling methods? So how can you reduce the data or filter the data? Types of bias, basic statistics, and in business analytics, create summary reports and interpret the reports. Those are the things we talk about. Maybe I'll do 2 videos instead of too many. So defining population and samples. Population includes all values possible in the study. So for example, you take Montreal, household salaries or income, Montreal household income. That means you have to include all households in Montreal and find out their income. So that is population. The size of the population here is a parameter by itself. The mean value, okay, once you find out from everybody in the Montreal, and you find out the mean value and the standard deviation, all of that can be, are parameters also of the population. So whenever you say population, the characteristics we talk about, we call them parameters. Whenever you talk about sample, so the characteristics of the data can be visualized as statistics. So you want to survey all restaurants in the country, for example. So that's a population. Population includes all observations possible. So population size, the mean, the standard deviation are parameters of the population. And evaluating all possible values is expensive. So you don't want to spend too much money for something which is anyway vague, right? Future is unpredictable. So, and but you want to really predict. So then you want to do it in a cheaper way. Evaluate the sample. Take a sample. So sample is a subset of the population. It's a representative of the population. So statistic is the sample size, for example, is a statistic. The mean value of the data points you collected in the sample is a statistic. The standard deviation. The minute you say sample, it is everything that you find are statistics. And based on the sample, you can infer or conclude about the population. First of all, understand this sample and find out the mean value, and you can also now find out, oh, this is the mean value, and the population mean is supposed to be the same or similar or close. So how close is it? Will you accept that as a acceptable within the limits? So That way you have infer also, there's an inference, conclusions about the population. So, for example, you do a survey of restaurants, instead of going for the entire, country, you probably select only 1,000 restaurants. That's a sample size, and find out the characteristics of the sample to infer about population. So this reduces the cost, obviously. Sample can be drawn out of the population in so many different ways. We're going to talk about it. Okay? So find out the statistics and try to understand the parameters of the population. Okay? Infer the parameters of the population. So in this, we talk about descriptive statistics. Describe the population and the sample. Describing the sample. Okay? Descriptive statistics. And inferential statistics. So when you are finding out the sample characteristic, what do you infer from there? So can you apply that to the population? Hypothesis testing is about association of the sample with the population. Oh, sample mean is this, population mean is exactly the same. That is a null hypothesis. Null hypothesis is the hypothesis that is a defective hypothesis, like accepting the characteristics observed inside the sample, you can associate that to population. And then find out more evidence, you can find out whether it is true or not. You can conduct several tests. There are several methods in statistics: t-test, z-test, p-test, f-test. Okay, there are so many ways of actually, inferring it. So, you know, and find out whether the population mean is actually the sample mean. So, sampling methods and data reduction and bias. Sample is supposed to be the reflection of the entire population. So that means you are drawing out of population. The sample is drawn out of population. So simple random sampling is a method where all elements are equally likely to be selected as an item into the sample. All elements are equally likely, are equal chance of selecting it. So stratified random sampling, it's still random, just like simple random, but you are stratifying or grouping the population based on certain, criteria, like urban versus rural. So gender wise, men, women, and gender wise, or any other means of categorizing the population into groups and finding out and taking the sample out of them in random again, random sampling. Equally, everybody is equally likely to be selected from those groups. And of course, you can decide upon, so how many from this group and how many from that group, kind of strategy for you. Cluster sampling is another method. Population is grouped into clusters, geography wise, time zone wise, whatever criteria that you want to put in, and you can group them. And again, it's like a grouping again. And those clusters, and you probably want to draw the proportions wise or something, some criteria you can put in, and draw the samples and then analyze. Convenient sampling means, okay, most economical way of sampling, ease of access and availability is the basic criteria. The data availability, you don't want to really spend too much money in finding out the data at the data points. Data reduction. Sometimes when it becomes too much, you can reduce the data. Okay? So R is not highlighted here. I'm going to highlight that. Okay, save it. So data, after you collected the data, you want to reduce it. So make it more manageable, a suitable size to the business analytics. Focus on the most critical and most critical facts that you want to really looking at. Are any abnormal items that are in the data you want to identify, like outliers or something? So, You want to eliminate them. Why do you want to keep outliers in your data? So anything, okay, which is not appropriate for your data points, so you can filter them. This filtering means removing the entities or the data points that are not good for your analysis. Sometimes, right, too old data. For example, the data is of 1920. It's not relevant. A car price and you're collecting the price of car, and car price in 1920 is obviously an outlier. So that's a stale data too, because it's a very old data. And irrelevant data, you eliminate them. So reduce it. So in that effort, filtering in Excel will help you. So make the filter and then go and try to find out. You can filter based on, you know, certain criteria and then eliminate them if you wish. In the last, lab one, we have done. So blanks were eliminated, okay, by filtering. And we found out the blank here and then eliminated that. So bias is a kind of prejudice. That means, we are all biased, some way or other. So you know what? So, you will try to help your people. That's normal. Okay, human nature. So in favor of or against a thing. For example, you know, you may, like something, you want to favor that. So in, a person or a group or whomever you want to favor or against a thing, against a person, against, a group. For example, among all the fruits, if I ask you, okay, you know which fruit you like, maybe apple. So you want to collect, so the favorite fruit from the population of Montreal. So you can influence people that, oh, don't you like apple? The question is not about apple. The question is about which fruit do you like to eat. But whereas you're asking a question, you're twisting when you are collecting the data. Obviously, you want them to say the apple is good. So that is intentional or unintentional. Sometimes people don't know they're doing it. So, and whatever way it is, bias is bias. When you use it in the data collection, or it could be used, in analysis because you want the result that you want to see. Okay, that is bias. When you are collecting the data, for example, some people don't even speak a word. That is non-response bias, which means in the data that you collected, a lot of people did not even speak. Your data is not a true representative of population. So when you are selecting, again, you have a bias. You don't want to, include certain groups into your study. That is, analyst is selecting inappropriate sample. Confirmation. We all have pre-existing beliefs. We don't want to come out of the belief. Okay? So we don't tell the truth. Even though we know that, we don't confirm. Confirmation, bias. Outlier. Outlier means extreme values. So obviously, those, if you go and touch them, their way of looking at the regular, okay, the behavior or characteristic is different. So now I think I'll stop at this point up and then post it so that you get a smaller videos.